Assalamualaikum and hello everyone. Welcome to the video where we'll be discussing past year question for the year of 2018-2019. In this video, we will discuss question number 2. Question A, the wavelength that produces a line B and bracket series is 2165.6 nanometer. First question, determine the transition that forms the B line. Okay, so what does it mean by this? To produce a line B in bracket series means that the electron will fall from a higher energy level to a lower energy level. Okay, and then when the electron fall, it will produce energy, and the energy or the photon, there's a specific wavelength and frequency attached to it. So in this case, our wavelength in this question is 2165.6 nanometer, which is equivalent as well as 216.6 exponent negative 9 meter lah. Nano means that it is exponent negative 9. Okay, so but then this is the only information that we know. Okay, the wavelength. So the question was determine the transition that forms the B line. So we have to mention the electron falls from which end to which end. Okay, so for Bohr's atomic model, there are some formula that you need to memorize. So first is energy is equal to negative RH 1 over n square, specific to only one energy level lah. Delta E is RH 1 over initial square minus final square, where the RH in this case must be 2.18 exponent negative 18 joule. Okay, and then this delta E, we can also calculate the wavelength or the frequency, because our H is our Planck constant, C is our speed of light. So in this case, again, the question only give us the wavelength. Okay, so the last formula that you have to memorize is 1 over wavelength is equal to RH. In this case, our wave number will be a different value lah. 1 over n1 square minus n2 square, where n2 must be bigger than n1. This question have given us the wavelength. So we have here our wavelength. Based on the formula, we also delta E is equal to Hc over lambda. We also have the formula 1 over lambda. But then again, because we're concerning about the transition, about the n itself, from which n to which n, so it is easier for us to use this formula lah, 1 over lambda. If you want to use this one, then you have to insert the value of wavelength, find delta E, then you have to use the second formula. It's fine, you still get the same answer. But then again, since we have the straight away one, we're going to use this lah. Okay, but then again, transition that forms the B line, it means that one of the value must be known lah. Cannot lah dua-duanya unknown. So the hint given is the bracket series. Okay, so again, Leman balik pasar, break putus. So bracket, break. So this is the fourth one. So it means that for the bracket series, our ground state is n equal to 4. But then we do not know what is the excited state, the higher energy level, we do not know. Okay, so we're going to use this formula straight away. When writing the formula, you have to put this one lah. N2 is bigger than N1 or N1 smaller than N2. It's the same one lah. But this one is compulsory for you to write. Okay, so again, the information is given in nanometer. Nano, it means that negative 9. So wavelength here must be in meter. So I've changed it into exponent negative 9. Okay, and then again, N1 must be smaller. So the smaller one, or our ground state, is 4 lah. So here I'm just gonna put down, this is 4 squared, this is x squared. So once you calculate the value, then you will get your x to be 7. Okay, but then again, the question asks, determine the transition that forms the B line. So it does not mention that it wants which line. So you have to mention lah, transition to is from n equal to, transition is from n equal to 7 to n equal to 4. Okay, so then you get the answer here lah. Okay, because the question wants about the transition. Okay, if you write down this one, you won't get the full marks lah. This is the question asked for, determine the transition. So now we know that here, it means that the electron fall from 7 to 4. Okay, So that's for question 1 Roman. Okay. Question 2 Roman. Calculate the energy emitted for the transition. Okay, so once the electron is released, it will form energy in the form of light. Okay, since we have our wavelength, so we can use either this one, delta E is equal to Hc over lambda, or you can also use delta E RH 1 over N1 squared, or N initial square minus final square. But since the question did give us about the wavelength, so we're just going to use this formula. When you calculate the value, you will get 9.18 exponent negative 20. But then again, when the electron falls to the ground state, energy is released, and the energy released means that it must be in negative value lah. So we have to add our negative value by ourselves. Okay, so this is when you use this formula. If you use this one, okay, again remember initial, we have calculated from the previous one, 7, we force to n equal to 4. So based on the calculation, you will also get the same answer lah. From the calculator here, 9.176. So if you round it off, you will get 9.18 exponent negative 20. But then again, if you use this formula, the value itself will get a negative 1. If you use this one, the value will be positive, but then the negative, you must add yourself just to show that the energy is released. Okay, so both will get the same answer lah. So that is the solution for question A2 Roman. Question 3 Roman. Another line C was formed with a wavelength of 1817.5. Here supposed to be nanometer lah. Question 3 Roman. Another line C was formed with a wavelength of 1817.5 nanometer. Explain qualitatively that the line B or C has the higher energy emitted. So for the line B, we have 2165.6 nanometer. Line C, we have another wavelength. So here I mentioned that explain qualitatively which of the line has the higher energy. So we know that based on the wavelength. Okay, so we know that the delta E is equal to Hc over lambda. So when we calculate from the previous calculations, question 2 Roman, we've known that the line B, we have this energy. So it's either you want to calculate the other energy for this value, or again, because the question mentioned about the explain qualitatively. So as we can see from B to C, the wavelength decrease. So when the wavelength decrease, what does it mean is that the delta E will increase. Okay, here because we know that it is inversely proportional lah from this equation. Okay, so how to write it down or how to answer the question. So when the wavelength is shorter or decrease, the delta E will becomes higher or increasing lah. So again, line C is where the wavelength decrease. So again, when the wavelength decrease, the delta E will becomes higher. Again, back to the question, dia tanya whether line B or C has the higher energy emitted. So the delta E, the higher delta E must be the one with a shorter wavelength. So we have to mention line C has higher energy emitted. Emitted means produced lah. Again, when the electron falls from higher energy level to a lower energy level, energy is produced in the form of light. Is emitted in the form of light. Okay, so that's the last question for question 2A. For question B, the electronic configuration of element D is 1s2, 2s2, 2p6, 3s2, 3p3. So question 1 Roman, give a set of quantum number for the 9th electron. So what is your quantum number? Quantum number is your NLMS. Nasi lemak memang sedap. Nasi lemak masak sotong. And LMS. Okay, so again, if you look here for the 9th electron here, so when you calculate, here you got your 2, here 4, so here 10. So for the 9th electron, it must be at 2p6. Okay, so for the case of 2p6 here, so we know that for this case, n is equal to 2, L is equal to 1. Okay, why? Because when L is equal to 0, it is S orbital. If L equal to 1, it is P orbital. L is equal to 2, it is D orbital. For the case of P, so L is equal to 1 lah. So for the case L is equal to 1, so the possibility or the probability of value of M, it will be negative 1, 0, 1. Okay, and the possibility of S is positive half or negative half. Okay, but then again, the question asks to give a set of quantum number. Okay, so to give a set of quantum number, so you must be specific lah. For each of the N, L, M, and S must only have one value. So this is the possibility. So from here, I'm just gonna write down my N, L, M, S is 2, 1, M, up to you, any of this value. So I'm just gonna take 0. S could only be positive half or negative half. Okay, so I'm just going to take positive half lah. Okay, so this is my set of quantum number. Again, this is a set, so it must be specific lah. If you write down in terms of this one, this is the possibility. Okay, so this is not yet the quantum number. So you have to be specific. Okay, a set only one. So if it asks you give the sets, give all possible, then you have to write down all lah. It could be or 2, 1, 0, negative half, or 2, 1, negative 1, positive half. It has many possibility lah. Okay, but then for this question, ask for a set. So I'm just going to take one. Okay, it's either you write down in terms of this, or you could also write down in terms of this. N equal to 2, L equal to 1, M equal to 0, S equal to positive half. Okay, this one is all the possibility, but for the specific, only one value for each of the N, L, M, or S. Okay, so that is for question 1 Roman. Question 2, draw the orbital diagram of the valence electron. Valence electron means that it is the outermost electron or our highest N. So highest N in this case is N equal to 3. Okay, so for question 2, they ask for the orbital diagram specifically for 3s2, 3p3. This is the orbital diagram. Okay, so again, the electronic configuration, there are two ways to write it down. Either this one as PDF notation or this, where this is what we call orbital diagram. This question asks for specifically valence electron. So for the valence electron, the highest N lah, N equal to 3. If they ask you to write down all in terms of orbital, so you have to start with 1s2. This case, valence. Okay. Question C, draw and label the 3D shape of orbital occupied by the valence electron. So this is the orbital diagram. So what does it mean, the 3D shape of orbital? Again, we have S orbital, spherical, P orbital, dumbbell, D orbital, our clover leaf shape. Okay. Again, based on the question, they ask you to draw the orbital occupied by the valence electron. The valence electron, again, our highest N, N equal to 3. Again, we have 3s2, 3p3. Back to question number 2. So to draw the shape, the 3D shape, okay, you have to draw the s orbital and the p orbital. Again, why? Because the valence electron here we have s, we have p. So we have to draw both. Okay, so how to draw the shape? First, what you need to do is you have to draw and label the axis. Again, this what I've drawn here, the x, y, z, but the axis is interchangeable lah, because this is about 3D. Okay, again, the valence electron, we have our s orbital. Okay, so for the s orbital, what is the shape? The shape is spherical. So again, you draw it spherical. Okay, and then make sure you have to sketch it to show that it's 3D. And then you also have to label, since the question asks for the valence electron, so this is 3s. Okay, so that is for the case of s orbital. Then the question asks to the shape of orbital occupied the valence, we also have P. So how to draw it? Okay, the same case, we have to draw and label the axis first. Okay, so for the P orbital, p orbital, the shape is dumbbell. Okay, and then there are 3 axes. Again, p orbital L is equal to 1. So m equal to -1, 0, 1. So for the p orbital, there is 3 possibility lah, 3 orientation. So up to you which one you want to draw. But first, I want to draw it in terms of x. Okay, so x. Okay, make sure it is dumbbell as well as you have to shade it. Then label it. This is 3px. Okay, and then for the case of p, it could be this one 3px. Then you can draw lah 3py. So again, when you draw it, it must be shaded and you have to label lah 3py. Okay, the third possibility, the last possibility is 3pz. So that is all the 3D shape of orbital when n is equal to 3. Again, based on the valence electron here. So even though as we can see, the last orbital that we feel is n equal to 3, L equal to 1 or 3p orbital. But then the question asks for the valence, means that the outermost or the highest n, it does include our 3s orbital lah. Okay, so the question does not mention specifically to draw all or only some of the p orbitals. So I'm just going to draw all lah. Okay, so that is for question 3 Roman. For Roman, explain the feelings of the valence electron in 2b3 according to the appropriate rules or principle. So again, based on our valence electron, where we have draw the orbital diagram, it is 3s2, 3p3. So here it mentioned, explain how do we feel this valence electron according to the appropriate rules and principle. So basically, all our electronic configuration, how do we write it down here, is based on these 3 rules. We have Aufbau, we have Hans rule, and we have Pauli's exclusion principle. So what we need to do for this question is that first we have to explain the theory, and then we have to relate back to the valence electron. Okay, so the first theory that I'm going to write down is the Aufbau principle. Aufbau principle mentioned that the electrons will fill atomic orbital in the order of increasing energy. So actually it's a ring diagram lah. If you still remember, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. Okay, back to your ring diagram. So which one that the ring is connected to, that one will be filled first lah. So that's why we fill 1s, 2s, 2p. So this is actually in the order of increasing energy. Okay, so this is the principle, but then we have to relate back to the valence electron. So how do we explain or relate back to the valence electron? We have to mention that the 3s orbital has the lower energy and is filled first before we fill in the 3p. The same goes kalau contohnya if you go into a bus, what are the first thing that you did is actually you're going to fill up the first few spots kan at the front. Okay, tapi ada certain orang suka duduk belakang, so up to you lah. But for the case of electron, dia akan suka duduk depan lah, lagi senang, less energy, senang nak masuk nak keluar pun will be easier lah. Okay, so that is for the first one, Aufbau principle. Okay, the next rules that we're going to look at, Pauli's exclusion principle. It mentioned that there are no 2 electrons that can have the same set of quantum numbers. So it means that for each electron, the NLMS will be different lah. So it means that each electron is unique. So there's no 2 identical. So how do we relate back to the valence electron? So in this case, we're going to look at based on the 3s orbital. So as we can see here, for the 3s orbital, we can see the electron will be filled with opposite spin. Because why? For the first one, if we write down the NLMS, would be 3, 0, 0, positive half. This one will become 3, 0, 0, negative half. Again, why 3? Because n equal to 3. Why L equal to 0? Because our s orbital. So when L equal to 0, our m is equal to 0 lah. Okay, there's only one possibility. S could only be positive half or negative half. So it means that again, the electron must have, no 2 electron can have the same set of quantum numbers lah. Electron must be opposite. Then here we get positive half, negative half. The electron cannot be this way or this way. Pun cannot. It must be, if in the same orbital, it has to be the opposite spin. Okay. Last but not least, the third rule that we're going to see. Hans' rule mentioned that when filling orbital with equivalent energy, it means that when the energy is the same, electron will fill singly and parallel spin before pairing up. Okay, the same case as I've mentioned before. Okay, if you go into a bus, what you like to do first is actually you like to sit by yourself, kan? Even though in a bus there must be two seats. There a pair. Okay, apa-apa memang kita akan isi one by one dulu. The same goes for the electron. First, you're gonna fill singly. If you have another electron, then it will pair up. Okay. Then the question again, they ask you to relate back to the valence electron. So just now we mentioned for 3s. For this one, we've mentioned about 3p. Okay, Hans rule mentioned when filling orbitals with equivalent energy. Equivalent means that it has the same energy lah. So we mentioned that 3p ni the same energy. 3s ni energy dia as a lower one. Okay. So it mentioned that electron will fill singly and parallel spin. So make sure when you fill it up, fill it with the same spin. If you want to fill the spin, all spin down, no problem. But make sure all must be parallel spin. This is accepted, but if you draw the arrow with with different spin, this one cannot lah. Make sure it is parallel spin. Then for example, if I have the fourth electron, then we start pairing up. Okay. The same goes kalau dalam bus tu dah kira dah memang dah tak ada tempat, barulah kita nak duduk dengan ada orang. Tak kisahlah kita kenal ke tak, kan. Okay, so that is for the Hans rule. Okay. So that is all. Okay, so for this one, not only you have to memorize the name or the rules, you have to memorize, or you have to know lah what each of the rule meant, and you have to relate back to the how to fill out the valence electron. Okay, so that is the solution for PSPM for the year of 2018-2019.